Hello, this is a question for linear algebra, and we are given that let W be a subspace of R4 spanned by vectors u1, u2, u3. Then find a basis and dimension for W. So we are given what is W? So what is W? W is a subspace of R4. Subspace of R4. I hope you know what is R4. W, this is capital W. And what is u1, u2, u3? These are given. W is, it is said that it is W with a subspace spanned by vectors this u1, u2, u3. So that means W is equal to span u1, u2, u3. What could be the basis for this W? If u1, u2, u3, these three are linearly independent, then W this will form a basis for W. The basis for W will be it itself, okay, and dimension will be 3. Now we have to check, is these three vectors linearly independent or not? How many vectors here are linearly independent and how many are dependent? So to check this, make the augmented matrix. Now I have already solved this problem in another procedure where it is very lengthy, and I hope I think you can solve like this way also. It will be short way. Okay, now the augmented matrix. Now you have to like this also. If B belongs to R4, any vector, then B is equal x1, u1, x2, u2, x3, u3. Where x1, x2, x3 belongs here. You can write this or you may not write this also. So start here. The augmented matrix. Is it visible? The augmented matrix. A the augmented matrix corresponding to 1 and taking B is equal to 0. Okay. B is any vectors in W. We are now taking B is equal to 0. This is a particular vector. B is equal to 0. That means 0 vector. We are taking 0. And 0 in R4, since B is in R4, so 0 can be written as 0, 0, 0, 0. Because we are going to simplifying our calculation. When we take B is equal B1, B2, B3, B4, our calculation was very tough. So thus we have to check whether these three vectors are linearly independent, how many of these are linearly dependent. Okay, so that is we have to check. So taking this the augmented matrix corresponding to 1 and taking B is equal to 0 is That means A augmented B, but we are taking B is equal to 0, it will be A augmented 0. We can write A augmented B, which is equivalent to A augmented 0, which is this. So you have to make a matrix 1 minus 2, 5 minus 3. 1 minus 2, 5 minus 3. 2, 3, 1, 4. 1 minus 4. It is minus 4. 3, 8 minus 3, 5. Minus 5. 3, 8 minus 3 minus. Now take here, since it is 0, A augmented 0, so it will A augmented 0, so it will be this 0, 0, 0, 0. And this matrix is equivalent, I write here. 1, 2, 3, 0. You have to make this row 0. This is 0. It will be, what operation will be taken here? R2 tends to R2 plus twice R1. Then it will be 0. It will be 7. It will be 14. And it will be 0. R3 tends to R3 minus 5R1. So this position will be 0. 5 into 2, 10. And 2 into 5, 2 into 5, 10. So 1 minus 10 minus 9. 15 minus 3 minus 15, it will be minus 18. And it will be 0. And this is will be multiply R4 times 2, R4 times 2, R4 plus thrice R1. So this will be 0 and it will be 6. 6 minus 4, it will be 2. 3. 9. 9 minus 5, it will be 4 and it will be 0. Calculation are easy now. Where we are taking 0. So it lines always it will be 0. So 1, 2, 3, 0, 0, 7. Divided by it 7, it will be 1, it will be 2, 0, 0. Divided it by 9, it will be minus 1, it will be minus 2, 0. Divided it by 2, it will be 0, 1, 2, 0. Operation, right here operation. What we have done? R2 tends to 1 by 7, R2. R3 tends to 1 by 9, R3. And R4 tends to 1 by 2, R4. You are dividing here by 7, here by 9, here by 2. Okay. This is equivalent to 1, 2, 3, 0. It will be 0, 1, 2, 0 and 0. Now what we will done with what we will do? R3 tends to R3 plus R2, because we have to make this 0, and to make this 0, R4 tends to R4 minus R2. So it will be 0, 0, 0. Now it will be 0. 0, 0. That means here this is the position of for x1, this is the position for x2, and this is the position for x3. x3 is free variable. x1 and x2 are basic. Okay. That means this is not equal to 0. Free variable, that means the position is equivalent to, position is 0, becomes 0. The position becomes non-zero. So here these two are linearly independent because uh, that means these two are basic variable. So corresponding to x1 it is u1, and for x2 it is u2. u1 and u2, these two are linearly independent vector in u1 and u2. So u1 and u2 are linearly independent vector in u1, u2, u3. In this set u1, u2, u3, only these two are linearly independent vectors. So linearly independent vector will form the basis. Hence, you can write here also. Hence, basis for W will be u1, u2, and dimension of W is equal to number of linearly independent vectors. Number of vectors in the basis. That is dimension of W is equal to how many? 1, 2. It is 2. So hence our answer.